Okay, so we're going to be looking at 3D figures today. We've got a few different types. We've got prisms. So a prism is a solid with two bases that are congruent and parallel. The bases of this prism right here are triangles. And basically we're just saying that these two triangles are the same and then the shape is sort of stretched out. But we can have lots of other types of prisms. We can have rectangular prisms. In a rectangular prism, you could pick any of the two sides to be a base. But we could also have kind of crazier ones. We could have like hexagonal prisms.
They're just the opposite of each other.
Yeah, so you basically have a hexagon, and then it would sort of stretch out like this. And you'd have a hexagon on the top, hexagon on the bottom, and the hexagon would be the base. It's not an amazing drawing, but it'll do. A cylinder is a special type of prism. It's basically a prism with circular bases. Or that's literally what it is. But we call it a cylinder. And then we have pyramids, right? You guys have seen pyramids before. We've got one base, and then the other sides that come out from that meet at a point at the top. Typically, we're going to see pyramids that have either a triangle base or a square base. The pyramids in Egypt, do they have a square base or a triangle base? They have a square base. But have you guys ever seen a four-sided die before? It's an example of a pyramid with. Let's see if I can find a picture here. Yeah. So there's a four-sided die right there. 1, 2, 3, 4, 1, 2, 3, 4. So that's a triangular pyramid. A cone is basically a pyramid with a circular base. And then we've got spheres, which is basically a 3D circle. We've got one center point. We have a radius that goes out. The radius is the same length in all directions. But it's just a 3D circle, like a ball. Okay. So for these here, we're going to classify the solid and highlight the bases. So for number 1, what type of solid is that? That is a pyramid. And where is the base? Yeah. Okay. And that's a good point. The base is not always going to be on the bottom, but in this case, it is. We rotate a shape. Okay. Let's look at number let's say 3. What is number 3? That is a prism. And what are the bases? The top and bottom, yeah. What shape are they? Triangles. So we would call this a triangular prism. Okay, number 6. What type of shape is that? Number 6, the pyramid. That is a prism. What type of prism is that?
Rectangle.
That is a rectangular prism.
So what would 4 be?
What would 4 be? A pyramid, yeah. Got a point.
What? But it's not.
It'd be a hexagonal pyramid. Okay, I want to look at number 6. Which ones are the bases?
Any 2 that are.
Exactly. Any 2 that are parallel. So rectangular prisms are special. Those could be bases. This one and this one. Top and bottom could be bases. It's going to be kind of, I'm going to end up covering the bases here, but just covering my bases. Or this side and the one behind it. So it's got 3 pairs of bases. So that one's kind of a special case. Okay, you guys do the rest. Classify solid highlights the bases. All right. Number 2. What kind of solid is this?
Oh,
That is a cone. And what is the base?
on the right side.
The right side, yeah. The circle. Okay, for number 4, what is the base of that pyramid? Number 4. We didn't have it.
At the bottom.
The base at the bottom, yeah, the hexagon. Okay, number 5, what is that?
Cylinder.
That is a cylinder. It's a very strange word to spell. Base or bases? Top and bottom. Circles. Okay, number 7. That is a prism. It's a trapezoidal prism. Yep. And where are the bases? Top and bottom? No.
Side.
The sides? Which side?
Horizontal.
There, I see 4 horizontal sides. The trapezoids and then the rectangles on the side. What shape are they?
They are.
Yes. The trapezoids are the bases.
So why at the top and bottom?
Because a prism is one shape that is basically stretched out. That shape is the base. Whatever type of prism it is, see number 3 here? The bases were the triangles. It's a triangular prism. If this is a trapezoidal prism, the trapezoids are the bases. A rectangular prism has 3 sets of bases because they're all the same, but every other shape so we need the ones that are congruent and parallel. That's another way to look at it, the ones that are parallel to each other. Okay, number 8, what shape is that? Pyramid. That one, what's the base? The square, yep. So it's just square base. Number 9? Pentagonal.
Oh, I don't know what to say. I said hexagon.
Yep. Yeah, the word, the adjective to describe it is pentagonal. That's not as important as identifying that it's a prism. So if it's basically a pentagon prism, the bases are the pentagons. They're the things that are parallel to each other that are congruent. And so, regardless of whether this pentagon is standing upright or on its side, the pentagons are the bases in a pentagonal prism. So the orientation doesn't matter. The pentagon's still the prism. That's an awful drawing. I'm going to erase that. I'm ashamed. Okay. Okay, number 10. What is that? It's a pyramid. The base? Triangle, which one?
One bottom.
The one at the bottom? Yeah, we could probably safely say it's the one at the bottom. It kind of looks like all of these triangles are the same. If that's the case, then any side could be the base. We don't really have enough information to say that, so it's probably safer to say the bottom one, but again, if they're all the same, it's got 4 bases, just like the 4-sided die. Number 11 was that? That's a prism. And what kind of prism is it? Huh? Rectangular prism? 11? No. Triangular, right? We got some triangles here. So a rectangular prism, everything's going to be a rectangle. Every other type of prism has rectangles in it, right? See number 9? There's rectangles on the side. Number 7, there's rectangles on the side of that. It's the other shape that determines the type of prism. So what are the bases in the triangular prism? The triangles. All right, and number 12. What is that shape?
Sphere.
Sphere. Does a sphere have a base? The sphere does not have a base, right? It's a ball. You just roll around. There's no base. Okay. We're going to look at surface area. What is surface area? What does that mean? Who knows what surface area means?
What's the question?
What is surface area?
Total, like the area of each side.
The area of each side added together. Yes, exactly. So it'd be like this area plus that one, plus that one, plus that one, plus this one, plus that one behind it there, yes. So imagine if we had a box and we were painting the outside. That's surface area.
I'm sorry to interrupt you. I just have 1 second.
Okay. So surface area. We have 2 different formulas for prisms. We have a special one for rectangular prisms, and we mentioned that they're kind of special because they basically have 3 sets of bases, whereas every other type of prism only has 1 set of bases. So with a rectangular prism, we just do this formula right here. 2 times length times width, 2 times length times height, 2 times width times height. So for number 1 here, that would be 2, and it doesn't matter the order that we do them in. Yeah, right. Be 2 times 7 times 13 plus 2 times 13 times 9 plus 2 times 7 times 9. And we would just type that into the calculator. You guys do numbers 1, 2, and 3. All right, let's check. So we put that into the calculator, and what do we get? $542. Okay, and we would say feet squared. We're using square inches for area. All right, number 2. Someone help me set it up. All right, and what does that equal? (580 centimeters squared). Yep. All right, and then the last one, number 3, what does that look like when we set it up? What is that, a 1.5 or 15? 1.5. So 2 times 11 times 6 plus 2 times 11 times 1.5 plus 2 times 1.5 times 6. And that is a 183 inches squared. Get that? Okay. So that's rectangular prisms. Just using that formula, you're going to have that formula. All other prisms, we've got a different method here, because we have 2 sides that specifically have to be the bases. Remember that whatever type of prism it is, this is a triangular prism. If it's got triangles in it and it's a prism, the triangles are the bases. Here's our formula for surface area right there. HP plus 2B. So H is the height between the bases right here. So again, those bases are the triangles. H is the height between the bases. P is the perimeter of the base. So in that case, it would be the perimeter of the triangle. All the sides added up. And then capital B represents the area of the base. So we've got everything we need right there. So HP plus 2B. So let's do number 4 together. What is the base of number 4? What kind of shape? The triangles. Okay, so there's a base. There's a base. And notice that these are right triangles. And we have all the sides that we need. Yeah. So what is H? We're doing HP plus 2B. What does H equal? 16. Yeah, the height between the bases. What does P equal? 36. How'd you get that?
I added all of the sides of the triangles together to get the perimeter.
Yep. So the perimeter of the base is 36, so that's HP. And then we need the area of the base. So if the base is a triangle, we need to use the area of a triangle formula. What is the formula for area of a triangle? 1/2 base times height. Okay. Is that H going to be the same H that we just used? No, it's not. That H that we used before is the height of the prism. This H is the height of what? The triangle. Yeah. So if we're trying to find the area of the triangle, we need to make sure we use the parts of the triangle. So what are the base and the height of the triangles? What is the base and the height of the triangles? We got 3 options. Pick 2. What are the base and the height? What are the base and the height of the triangles? Here's our triangle, right? We have 9, 12, 15. It's a right triangle. You can see the right angle there at the bottom. Yeah, what are the base and the height? The base is 9. The height is 12. Right? Look at that. Base and height. They're right there. 9 and 12.
So when you use the height of the whole thing,
That we use for this h right there.
how do you know the difference?
One is the height of the triangle, the other is the height of the prism. So what we're trying to do is we're trying to find surface area of the prism. That formula is HP plus 2B. That means the height of the prism, the perimeter of the base, plus 2 times the area of the base. When we go to find the area of the base, we need to know how to find the area of a triangle. This is a triangle. It's 1/2 base times height. It's 1/2 12 times 10. So we put that together. 16 times 36 plus 2 times whatever 1/2 9 times 12 is. 54. And what does that equal when we put it all together? Yep. We would say meters. Okay. For number 5, what are the bases of that prism? What are the bases? Number 5, what are the bases? Hello? Yeah. The 2 triangles, yes. Okay. So that's one of the bases, that's one of the bases. So when we're using HP plus 2B, we need to use that. For number 6, what are the bases of that prism? What are the bases? The trapezoids. Okay. Use the formula, find the surface area of the other 2. Okay, let's check these.
Wait.
So for number 5, it might be helpful for you guys to draw the base separately.
No, that right.
Imagine being that.
Shut up.
Okay, so here's something that I like to do sometimes is draw the base separately. This is the base of the prism, the triangle. So what does H represent again? The height between the bases. Guys, what is the height between the bases? Huh? 3. The height between the bases is 3. That's not the height of the triangle, that's the height of the prism. What does P stand for? Perimeter of the base. Okay, that's the perimeter of this triangle right here. What's the perimeter of that triangle? $27. 5 plus 10 plus 12. Then capital B is the area of what? The base, which is this triangle. So how would we find the area of that triangle? 1/2 base times height. What are the base and the height? 5 and 10 would work if this were a right triangle, but it's not. What would we say the base and the height of that triangle right there? Not 12 and 10. Nope. Awesome. 12 and 4.1. Right? There's the height right there. The altitude. Okay. So the area of one of those triangles is 24.6. 1/2 times base times height. So in our full formula here, HP plus 2B, H is 3, P is 27, plus 2 times 24.6, we should get 130.2. Okay, here's something, let's review this on triangles. How many bases does a triangle have? Guys, listen up, please.
3.
A triangle has 3 bases. How many heights does a triangle have? 3. A triangle has 3 heights. They're also called altitudes. So, height 1 and base 1 go together. They could be used to find the area. Here's height 2. It measures from the base to the top of the triangle. If we were to rotate it or turn your head sideways there, you can see it. And then the third height goes from the third base to the top of the triangle. They actually do all intersect in the same point, which is a fun fact. But we need to use a base and a height that go together, that intersect each other, that are perpendicular. So if I was trying to find area, I could use height 1 with base 1 to see how they meet like that. I could use height 2 with base 2. Those are the ones that intersect each other. Or I could use height 3 with base 3. And it all depends on the information that we have in the triangle. So with this triangle right here, and number 5, how many bases do we know? Oh my gosh. How many bases do we know of this triangle? How many bases do we know of this triangle?
1.
More than 1. 2. More than 2? How many bases do we know of this triangle right here? We know all 3, right? Do you see them? Do we see them? Do we see them? Right. Okay. 1, 2, 3. We know all 3. We have to use the height that intersects the base. Which one intersects one of the bases? Or which base is being intersected by the height? The 12, right? The 12 is getting intersected by the 4.1. That's why we use those 2. In this previous example here, when we have a right triangle, in a right triangle, we have 3 bases, but 2 of them can be used as the base and the heights because they have a right angle. We always measure the height at a right angle. Okay. What is the base of this prism again? Number 6? What is the base? What is the base? The base, the trapezoid, right? Okay. This is the base of the prism. When we're talking about HP plus 2B, H is the height between the bases. What does that equal? 15. When we do perimeter, what sides am I going to add up? 20, 18, 12, and 23. Yes. The perimeter of the base. The base is here, the trapezoid. We're finding the perimeter. So that's HP plus 2 times the area of the base. How do we find the area of the trapezoid? Area of a trapezoid is 1/2 H B1 plus B2. We have a formula sheet. Make sure we use it. 1/2 times 12 times 18 plus 23. So we have 15 times, what does this equal? 73 plus 2 times whatever. 6 times 23 plus 18 is 246. Oops. That's 1187 square feet. Okay. We have the formulas, right? We have what they mean. We have what the letters mean. We know how to find the area of a trapezoid. You gotta be able to put all these things together. You gotta be able to look at the picture and match it up with what's on the formula sheet. Questions on how to do this? Okay. Let's look at pyramids and cones. Actually, let's look at cylinders first. Okay. For a cylinder, surface area is 2 pi r squared plus 2 pi r h. For this, let's just use pi as 3.14, but we could put it in terms of pi if we wanted. R is the radius of the circle that's on the top and the bottom. And H is the same as the height of the cylinder. It's the height between the bases, just like it was for a prism. So for number 9, my formula is 2 pi r squared plus 2 pi r h. That's 2 times 3.14 times 11 squared plus 2 times 3.14 times 11 times 26. It's already set up for us pretty much. You can just type that into the calculator like that. Yeah, I got 2,555.96 yards. It was a big cylinder. Yeah, 26 yards, quite a lot. The other one's pretty big too. Okay, you guys do number 10. Okay, surface area. 2 pi r squared plus 2 pi r h. What does r equal? $7.5. And what is h? 9. Okay. Again, we'll just use 3.14. What do we get when we type that into the calculator? What does that equal? 70. Wait, what is it? Okay. Questions on that? All right. Let's go to the next page. Let's talk about pyramids, cones. Okay, for a pyramid here, our surface area formula is 1/2 LP plus B. So we're adding in a new measurement here, L. L stands for the slant height. So that's not the height of the pyramid, that is the distance that you would walk up the side of the pyramid. if you're going to walk up it. So there is a height of the pyramid. We use that for volume. And the height and half of the length of the base here and the slant height form a right triangle. So that's going to be helpful to us. And then B, capital B, still equals the area of the base. LA stands for lateral area. That's the area of the bases of the pyramid. We don't really need that. So for surface area of number 1, it would be 1/2 times L times P plus B. Do we know L in this pyramid?
Yeah.
Yes, we do. What is P?
32.
32. So we add all those 8s together. And then the area of the base. What the area of the base? 64. All right, we just do, it's a square, so we do 8 times 8. 4. And that is our surface area. Oh my God. You guys do 2 and 3. All right, guys, let's check. So for number 2, 1/2 LP plus P. What is L in number 2? 7.4. What is P? What is it?
Is 20.
Okay. And then B, the area of the base? 25. Okay. When we put that into the calculator, what do we get?
99.
99? Okay. Number 3. So we're missing L, the slant height. How do we find that?
Pythagorean theorem.
Pythagorean theorem, yes. So the slant height, the height, and half of the length of the base here make a right triangle. So we would just do 3 squared plus 8 squared. Get the square root of 73. We can use that in our calculations and round at the end, or we can round it now, or we can use a radical. So we have some options. But we're going to do 1/2 times root 73, not 37, 73. What is P in this one? All right, you guys. Guess. What is guess? What does P equal? 64. And then the area of the base? 256. So depending on when you round, we might get slightly different answers. But if I use the root 73 and I round at the very end, I get 529.41. But if you round earlier than that, you might get something close but slightly. Okay. Let's go to the next page here and let's take a look at cones.
Jackson? Let's see how long that lasts.
Okay. Cones, we have another formula here. Pi r squared plus pi rl. L is the same thing. It's the slant height. Notice the height, the radius, and the slant height all have the same right triangle interaction here. Hey guys. You stop talking while I'm talking. So our surface area formula is pi r squared plus pi rl. And we've got all the pieces we need here. So we'll just use 3.14. So 3.14 times 7 squared plus 3.14 times 7 times 11. Remember that if we were missing one of these things, we could use the Pythagorean theorem to find it. Okay. You guys do number 8. Okay. What is the radius for number 8?
13.5.
13.5. And do we know L, slant height?
32.9.
13. Okay. So all we have to do is pi 3.14 times 13.5 squared plus 13.4 times 13.5 times 13.9. So you guys get 1415.826?
No.
No?
I got
Oh, wait, sorry.
1966.
Yeah, 1988.091.
1966.
1966. Okay. I must have typed something wrong. 1966 point
896.
896. Okay. On number 9 here, what are we missing?
Slant.
We have the slant.
Oh.
We are missing the radius. Okay, what would we use to find the radius? Yeah. So I'll just set it up for a sphere. Yeah. Hey, let's turn to page 29. Okay.
What page?
29. Okay, look up here for a second, you guys. On page 29, we're looking at spheres. We have 2 formulas for surface area for a sphere. If it's a full sphere, it's 4 pi r squared. If it's a hemisphere, it's 3 pi r squared. So here's why it's not 2 pi r squared. Because we have a circle on the bottom of the hemisphere, or on the top, that we now include as part of our surface. That's why it's not 2 pi r squared. Okay, so those formulas are there. They're in the packet. They're on page 29. They're also probably on the front as well. Your homework is Delta Math. I'm also going to come around and check your homework right now, so don't pack up yet.